Good morning. Welcome back to Math Minutes with Vozzy. It has been a few minutes. It's been a hot minute since we had a video, and I wanted to do this one. I'm going to kind of get you started on most of these, but on some of them, I'm going to actually work them for you. But just keep in mind, this is for a grade, and you will be putting it into a ground for your answers. So, a bike rental company charges $50 for the first hour. So that's going to be $50 for the first hour. $25 for each additional hour. Michael must spend no more than, and I apologize, my little soft tip that I usually have on my pen in order to keep it from sounding like a chicken is pecking on the glass. I don't have any of those here with me, and so it's going to sound a little bit like chickens writing with my iPad pen, but I apologize for that. No more than $200 on his rental for the day. What is the maximum number of hours that Michael can rent a bike? Write and solve an inequality for this scenario. All right, so when we're writing an inequality, we're going to use the same process that we do when we write an equation. From a word problem, we're going to need a variable term plus a constant term. This will be our inequality symbol. And then we will have a total or an amount left over, depending on what we're doing. Okay? So we've got to decide what's our variable term and what's our constant term. $50 for the first hour and $25 for each additional hour. So which one of those is going to be the variable? Which one's going to be the constant? Well, there's one word that sets them apart. There's one word right here that sets this apart, and it's right here, the word each. Each additional hour tells us that that's the variable term, because it's going to be $25 per hour for any hours beyond that $50. So the $50 is our constant term, because the $50 you're going to pay no matter what, because he's going to come and probably stay an hour. So, or you're going to at least have the bike for an hour. It's going to be $50 no matter what. So that's going to be your constant term. That's set. That's what we call facts. That ain't going nowhere. $25 for each additional hour. The word each is telling us that's a variable term, because we don't know how many more hours we would have. And then no more than $200 would be our total. No more than is the other word that is kind of critical right here. And so I'm just going to double check, make sure I'm still recording. I am. I don't want it to stop recording. No more than. He cannot spend more than $200. So the no more than here is going to be a less than or equal to. Because he can spend $200. He can spend $150. But he cannot spend $201. Okay? So our sign here is less than or equal to. Our total is 200. Our variable term was 25x. And our constant term is 50. Okay? So now we are going to just solve. We don't have any simplifying that we have to do. So we're going to start with subtracting 50 from both sides. We're going to subtract 50 from both sides. And we get 25x is less than or equal to 150. Now we divide both sides by 25. And x is going to be less than or equal to. And you're going to put that in your calculator, and you get 6. So the maximum number of hours that he could rent a bike would be for 6 hours. So we're going to write us a statement that says, Michael can This is where it sounds like a chicken pecking. Michael can rent a bike for no more than 6 hours. All right. Number 2, Ken has $950 in his savings account at the beginning of the summer. He wants to have at least $600 in the account at the end of the summer. He withdraws $35 a week for entertainment. All right, so we've got to have a variable term. Now, we're going to be taking money out. A constant term, our inequality symbol would go here, and then we're going to have an amount left over. This is where we'd have an amount left over rather than a total, okay? So let's pick it apart. He has $950 in savings. He has that much in savings right now. A lot of times now you're going to want to migrate to that $950 to be the amount that's on the right-hand side of your inequality. It's not going to be, because if you look right here, you see at least $600. At least $600 is going to be the amount he has left over. At least $600 means he wants to have $600 or more. $600 or more. So the amount that he has left over needs to be greater than or equal to $600. He withdraws $35 a week for entertainment. That's $35 per week. That's $35 per week. If you think about the word per, pointing us to our variable term, we have $950 would be our constant term, $35 a week would be our variable term, and at least $600, this would be our amount left over. So I'm going to leave that one there. I'm not going to solve it. I've given you enough that you should be able to figure that out. So you're going to write the inequality for number 2, and then you've got to solve it for number 3, okay? So that goes together with those. Amy has $1,000 in savings at the beginning of her vacation. She wants to use some of the money for fun activities during her vacation. But wants to have at least $500 in her account when she returns. This one's a lot like the one right before it, okay? This one's a lot like the one right before it. I tell you what, I'm going to go back to this one. No, I'm not. This is a lot like the one right before it, okay? She has $1,000 in her savings account. So we're going to highlight the important stuff first. She wants to use some of the money for activities, but wants to have at least $500 in the account when she returns. She withdraws $100 per week. $100 per week. All right, so first, $1,000 in her savings account. That's how much she starts with. That's a set amount. That's your constant term. $100 per week is your variable term. She wants to have at least $500. That means $500 or more. The least amount of money she wants to have is $500. So she wants to have $500 or more. So that's going to be greater than or equal to and $500 is going to be your amount left over. Okay? All right. You're going to write the inequality, solve the inequality. You and your family attend, so I'm on number 6 now because number 4 and 5 are right there. You and your family attend your brother's championship baseball game. Between innings, you decide to go to the snack stand. You go to the snack stand with $15. You find that sodas are $2.50 a piece and popcorn is $3.75. Write an inequality that models the number of sodas you can buy if you get a bag of popcorn 2. What is the maximum number of sodas you can buy in this situation? Okay, so you go to the snack stand with $15. Sodas are $2.50. Popcorn's $3.75. All right, so you have $15 to spend, and the amount of money you spend cannot exceed $15. That's all you got. If you spend $16, you're not going to have enough money. So the amount of money you spend is going to have to be less than or equal to $15, okay? The only way to know which one of these you are going to use as your variable is from the question. The question actually tells you what your variable term is here. What is the maximum number of sodas? So you know how much the sodas cost, but you don't know how many you're going to buy. You don't know how many you're going to buy. So your sodas are going to end up being your variable term here, and the popcorn is going to be your constant term here. So you need to write this inequality and solve it to get and then choose the answer that has the correct inequality and the correct answer. Okay? For each of the diagrams below, write the expression and simplify the area or the perimeter. All right, I'm going to come back up here for a minute on this one above it, and I'm just going to give you this again. That's your inequality symbol, and that's your total. Just to give you a little help there too. Okay, for each of the, all right, so diagram A says find the area of the rectangle. So we know, all right, so it says find the area. We know that area equals length times width, okay? So we got to have a length and a width. Well, here's our, and you know that I've told you, and keep this in your brain, I always use if the model has a constant term as a length, if it's not using two expressions, I use that as my length. So I'm going to let this 4 right here be my length. And this 2x plus 6 be my width, okay? And I'm just going to put that into my area equals my length is 4. My width is 2x plus 6. So now I'm ready to simplify this by using the distributive property. 4 times 2 is 8x. 4 times 6 is 24. And that's all I can do. So the area is 8x plus 24. Okay? I just did diagram A. Diagram B, you're going to set it up exactly like diagram A. Okay? I'm going to do I may do both of these last ones, we'll see. So this one is asking you for, so you're going to do this one all by yourself. I'm not going to give you any help on this one. Okay? You're doing that one, just like the one I just did. Diagram C is asking for the perimeter. Got to read real careful right here, the perimeter. So now we've got to make sure with perimeter, hold on, let's see. Trying to erase, sorry. I'm just going to, when you're finding perimeter, I'm going to blow this up a little bit. When finding perimeter, you want to label every side. You want to label every side first, okay? Label all your sides. So if this is a rectangle, if this side is 3x, this side's 3x, this side's going to be 3x too. So I'm going to put a 3x right there. If this side is 4, this side's going to be 4. Okay? Now I can do my ring around the rectangle. You ready? I'll start right here. I'm going to write them down and stack them. 3x plus 4 I don't have a variable to put right there. Plus, actually, well, 3x plus 4. I may go back and do that a little bit different. Show you a different, this one's a little, so 3x and 3x is 6x plus 8. And that's the perimeter. This one would have been really easy, just to say, okay, I've got 3x times 2 plus 4 times 2. 2 times 4. You could have done that, which would have given you 6x plus 8. You've got 2 3x's and 2 4's, so you could have just multiplied those. Either one of those work, okay? This is a little bit confusing because you don't have a variable term to put right there, and you don't have a constant term to put right there. You don't have a variable term there, so they look weird lined up like that when you stack them. So if you want to do it the other way, it's fine too. So on diagram D, again, we're going to label, it's asking for perimeter, so we're going to label every side first. This is x plus 6. But I don't have anything on the other side. Oh my goodness. There's another key word here. It is a square. And if it is a square, all the sides are going to be the same. So make sure you pay attention to that. Okay? Now you're just going to stack them up. X plus 6 plus x plus 6. See how much better they stack because they've got a variable and a constant. Plus x plus 6 plus x plus 6. And I've got all 4, so now I'm going to add those up. You're going to add your constant terms right there plus your variable terms right there. And I'm going to stop right there and let you do the rest of that one. Okay? And then the last one, find the area and perimeter of this figure. All right, so first thing we're going to do for this, I'm going to make it a little bit bigger, give me some room. First thing we're going to do for this is we're going to label all your sides. Let's get them all labeled first. All right? Let's get them all labeled first. Well, I know this is 4x plus 4. So I don't know this. But I do know this. I need you to pay attention to this. That is a geometric symbol for showing equality. If you see a little hash mark here and a hash mark on both, that is telling you that this is 4x plus 4. And this is 4x plus 4. That's how you know how long that other side is. 4x plus 4 and 4x plus 4. So if I put, I'm going to use some, okay, so if I put this side, if I put this side, if I put that side, and this side, I need to make that a little bit bigger, and this side, so I'm taking these two sides that are the same. If I put those two together, I get this whole side. I get that whole side. So this side down here is going to be 4x plus 4 plus 4x plus 4. So when I put my 4x's together, that's 8x. And I put this 4 and this 4 together, that's 8. So this side is 4x, is 8x. This side is 8x plus 8 when I put those together. Okay, so there's that side. So we've got that one and that one. Now we've got to get this long one. And again, if I put this side with this side, I'm going to get this side. So 7 plus 4 is 11. Okay? So now, I'm going to say, in order to find that, we got to find the area and the perimeter. Let's do area first. Let's do area first. Okay? So we're going to do area first. And area equals length times width. The problem is we've got to find the area of two different rectangles. I'm going to separate these two rectangles right here so that I can have a length and a width for two different rectangles. So if you look right here, this rectangle and I've got this rectangle. And I've got to find the area of each one of those and then add them together. So the area of the pink one, this is going to be my length. This is going to be my width. Because that's one full side and another full side. I can't use the 7 because it's not a full side of that rectangle. So my length is 11. My width is 4x plus 4. When I distribute that, I get 44x plus 44. That's the red one. For the blue one, I'm going to use this as my length, and this is my width, so that I've got a full side and another full side. My length is 4. My width is 4x plus 4. So this is 8x plus 8. Let me move that over just a little bit so I can have enough room. 4 times 4x plus 4. When I distribute, I get, and I did it wrong, 16x plus 16. So now I did it right. I did it wrong to start with. I added those instead of multiplying them. Look how easy that is to do. Now I've got to take this and add them to have the area of the whole thing. So I've got to take 44x plus 44 and 16x plus 16 and add them together using my calculator. And it's 60, so the total area is 60x plus 60. The total area here of that rectangle is 60x plus 60. But we're not done because it wants us to do the perimeter too. So now we got to stack them all up. Now we got to stack them all up and add them. So we're going to start up here with this 4x plus 4. 4x plus 4. This is perimeter. Then we're going to come here and get that 11. Put it right there. Then we're going to come here and get that 8x plus 8. Then we're going to come here. Oops. Then we're going to come here and get that 4. Then we're going to come here and get that 4x plus 4. Then we're going to come here and get that 7. See how I'm doing that to make sure I pick up every single one I need? Then if I get it back up here, I'm done. So now, I'm going to, in my calculator, add those. 4 plus 8 plus 4. 4 plus 8 plus 4 is 16. So I get 16x plus, and then I'm going to come back to my calculator, and I'm going to add all these up. 4 plus 11 plus 8 plus 4 plus 4 plus 7. And I get 38. That is the perimeter. And we're done. Once you get finished with this, get your answers into Wayground. And we will go over this a little bit more tomorrow and answer any of your questions. And be ready to take our assessment on Thursday. All right, let me know if you need me. Love you, mean it.